Number 16. Moving on with, continuing on with the ideal gas law. Determine the number of moles of a gas contained in each of the following. So I'm taking this same equation that I've been using, the ideal gas law, PV equals nRT, and now I'm solving for the number of moles, which is that N value right there. Boom. Get N by itself on the side of the equal sign, right? Rearrange it to solve for N. We have N is equal to PV over RT, and I'm ready to solve. Now, as I look through A, B, and C, I want to make sure that my units are correct. The easiest R to remember, at least for me, is 0.0821, but I only get to use that value when my units are number of moles, liters, kelvins, and then atmospheres. And so let me scan through A, B, and C and make sure that's what I have here. I have liters, I have degrees Celsius, so I'm going to add 273 to this. That'll end up being 300 K. And then atmospheres. Okay, good. Go down to C. This is in milliliters. Okay, milliliters. That's easy enough to convert. All I need to do is get rid of this milli, which is a thousandth. So I'll just move this 1, 3. So that's going to be 0.00750 liters. I have liters, and then I have a negative degree Celsius there. So let's see. Where is my negative sign on this one? Oh, there you go. Negative 50 plus 273. And I put 223K. And then atmospheres. So as far as this goes now, as I look at this problem, I have everything set chug now. I have the equation that I'm going to use. I have all of my quantities in the correct units, using the correct temperature scale as well, if you want to say that differently. So let's get going. N is equal to PV over RT. So pressure, 1.06 atm. Volume is 1.25 liters. R, I made sure that that's the value for R, so we're good to go. And then my value for T is 250K, and I'm ready to calculate. So 1.06 times 1.25, and then that's on the numerator. My denominator is 0.0821 multiplied by 250, and I come up with that bad boy. But look at all that calculator volume, sig fig, so I'm going to stop right there. But that 5 tells me to round that up, so 0.0646. And what's my unit here? Atmospheres cancels with atmospheres, liters cancels with liters, kelvins cancels with kelvins, so it is moles. Good thing, that's what the question is asking me for. Always make sure that you're solving for what the question is actually asking for. All right, N is equal to PV over RT. Pressure, 0.925 atmospheres. Volume, 0.80 liters. Ideal gas constant, 821. Got liters, atmospheres, and moles times kelvins. And then my temperature was 300K, because I had to turn it from degrees Celsius into kelvins. And I am ready to calculate. Parenthesis up for my numerator, 0.925 times 0.8, all over 0.0821 multiplied by 300, and up with 0.03, and I'm wanting to use 3 sig fig still. Right, so I'm going to stay right there, that second 0. Oop, I missed that. That's another 0, yeah. 0.03 moles. Cool beans. And C, I already have some of those units changed up, so I'm good to just plug these in. Pressure, 0.921 atm. Volume, I had to change that into liters, so I have 0.0750 liters. My ideal gas constant, and then my temperature, which is 223 K. And I'm ready to calculate. Parenthesis up for my numerator, 0.921 multiplied by 0.0075. That's my numerator all over 0.0821 times 223. All right, now I have a number that's in scientific notation right there. Looks like it's in proper scientific notation, so I'm going to go ahead and leave it. And I want 3 sig figs. Yeah, 3 sig figs, so 3.77. 3.77 times 10 to the negative